Hello and welcome to the course. Okay, dear audience, we also lack of trust data and we need to also obtain that. I sometimes wonder why I'm doing this if I haven't got any data to simulate. Well, we are creating them. How nice it is. Anyways, so in this lecture, we're going to learn how to obtain our trust data. What we will learn is that obtaining trust data via GasTurb, which is a commercial program that some engine companies use it, and the other one is via MATLAB. I mean, we'll create our own simulation or program, let's say. Okay, now I'm going to talk about GasTurb first, then the next video will be about MATLAB. So to analyze, I need some data, and here is the data I have. This data I obtained from our reference 1, Mattingly's book, named as Elements of Gas Turbine, if I don't remember wrong. Anyways, so like I said, there are not built-in functions in GasTurb that I'm going to show you after this. Therefore, we need to model our own engine and compare it with the real data. And here it is. Our engine is J85GE5H and it's a turbojet. And we have the maximum thrust with afterburner on as 17.13 kilonewtons. And we have SFC. Airflow is important. It's about 20 kilograms per second. And we have 7 overall pressure ratio with 8 stages, and we have turbine inlet temperature as 1166.5 kelvins. And finally, we can see the applications of the engine, which is the T38 that we are going to simulate. So these are important because now we're going to enter those data to the GasTurb program. And how do we do that is as this. This is the interface. But I'm going to first show you what we're going to change by highlighting here. Then I'm going to open the program. We're going to change the mass flow and intake pressure ratio. We're going to decrease it a bit. Pressure ratio and burn exit temperature. That's all. And finally, we're going to add the reheat exit temperature, which literally means afterburner. Okay, so let's open the GasTurb program. Well, it gives me this because I requested the trial license, and it says that your timing is almost up, and that's why I'm rushing to record this video. I told them that I'm going to use the GasTurb as an educational purpose. So I'm simply going to say OK, and it will open up the program for me. Okay, the interface is relatively easy. And as you can see, let me full screen. We have lots of engines here, but we're going to use only turbojet. I simply click that, and I'm going to select the turbojet with afterburner. And here it shows the station numbering, and I'm going to first design here. Okay, you remember the points here. So I'm going to enter the data I showed you here, like this. And actually, I remember them, therefore that will be no problem for me. So this 19.6096, and do not put a dot here because this is European. I mean, in Europe, we use commas instead of dots. I'm gonna reduce this slightly because I'm assuming that the engine is so old that the intake pressure ratio can be lower than 0.99. The pressure ratio is 8, and we have the burner exit temperature. Now it is 1166.5. I don't remember. I made the mistake. It's a comma. Yes, let's check that. Let's see. Okay, and I'm gonna reduce this a bit, like this. I'm also assuming that the engine is old enough so that the efficiency is not that high. Anyways, I will continue by selecting the reheat and its input. And actually, we do have to perform a reverse engineering here because I don't know the reheat exit temperature. I mean, we do have to try one by one. For example, if I run by 109,000, sorry, 1,900, we have a thrust force which is 19.56 kilonewtons, which is slightly higher because, like I said, I am after this. Therefore, I'm going to reduce that to value of 1,800. And now I'm going to run the program. And as you can see, we are closer to that number. I mean, I'm assuming that this is slightly better. And I'm not going to waste time to cache the exact thrust value. So this is nice. This is how we perform a on-design analysis, let's say, but we need an off-design analysis to perform a full mission profile analysis. I mean, if our airplane is going to perform a full mission profile analysis, and you know that the engine is installed to the airplane as well, so the engine has to meet the same performance specifications as the aircraft should do. Therefore, I'm coming back to the main window, and I'm now selecting the off design option here, and I need parametric analysis, and I don't have to change anything here. So I hit the parametric button. So I need to change the parameters, which will be altitude and Mach number respectively. So I select altitude first, and I want a sweep between 0 to 16,000 meters. It says meter here. And number of values of 17, so that I want a difference between 1,000 meters, 1 kilometers. Okay, this is 1 altitude, and I need the second parameter as the Mach number. And so I select this. And I simply start from 0, and the end value will be, again, let's say, let's preserve the consistency, and let's say 1.6. And again, don't forget to add the comma here. And again, number of values are 17, so that I have a difference between 0.1 Mach number. So this is it. I mean, we are ready to analyze, so I simply hit the run button here, and it simply gives us the results. All right, this is a engine carpet, but we're not interested with that. We are interested in a 3D plot. But I don't know how can I show you a 3D plot from the GasTurb interface. Instead, I'm gonna export the data to Excel file, and we're gonna read that file via MATLAB to both obtain the thrust lookup table and to show you the 3D plots. So that's how a engine behaves depending on the Mach number and the altitude. So to export, we have a option here to Excel and text file option. I click that, and it wants me to initialize a Excel file for that. So I hit the button and I say yes, and it asks me to what should I demonstrate to you? I mean, I can say that I want to say all inputs and I want to obtain all outputs, and I say start export to Excel, and it should open up to me an Excel file. Let's see whether I did or not. Here we have, this is a empty Excel sheet, and if I press the export button and if I say OK, it will start to print the required data here, slowly, one by one. I mean, of course, we're not gonna wait this to be completed because I have already performed the analysis. So we have a already completed Excel sheet, and as you can see, it is so much, and my PC can't handle this right now. Anyways, okay, this is the GasTurb program, and we obtained what we need to obtain actually. The next step is to write a MATLAB program and read the data from this Excel sheet. So I'm going to simply go to the MATLAB, and here's my workspace. And now I'm going to write my program. So let's get started. let's get started by creating a struct data, which is assigned to a variable that's called files. And let's say struct like this. And I'm gonna create a different file as the files, and I'm gonna say dry, which corresponds to the afterburner off situation. And I'm gonna assign it to the file name. And as you can see, I have my Excel files in the path. And as you can see, this means the reheat is on. So this is afterburner on, and this is afterburner off. So I'm gonna, can I copy this? I can only copy the path, right? Yeah, I can copy, but it won't copy the name. Okay, so I simply do my job here, reheat and off. This is for dry, and I need the same thing for wet, which means afterburner on. Let's say wet, and I can delete simply this. Okay, now I just define the output file name as output mat, and let's equate it to let's copy this and have the naming of G85. Let's say engine performance or data, whatever you'd like to call, let's say mat. Okay, now we need the main processing loop. So we do have to divide the main process into two, one for dry and one for wet. So we're gonna obtain two different lookup tables, and we're gonna combine them. So to do that, I'm gonna create the mods, and I'm gonna use a MATLAB rules function that helps me to perform what I would like to perform, let's say. It's called file names, and as input, it gives me files, semicolon. And let's create a struct for storing the engine data as engine data. How unique is it? Struct, semicolon. And now I can get to the loop, and I'm gonna need a for loop. It actually does this for me, so I'm gonna have this help. So from I to length mods, which is 2 actually. So 1 for dry and 2 for wet. This is what we're gonna perform. And so we don't need those for now. Let's delete this. Okay. Now I'm gonna say mode. Let's tab this as modes, and it will be a cell, therefore this curly braces and I. And the file name will be files dot mode. So if the mode is dry, let's say, the file name will be files dot dry, and this means actually this. So this is a clever way. Okay, so we need to create a function here, but I'm going to create the function in the end of this program, let's say. So, but again, I can at least construct that here. So we're going to need a function that will yield us Mach vector. Yes. And altitude vector. And I'm going to say that h to that. And trust map. Let's say. And SFC map, because we can also obtain that. I mean, GasTurb yields us that. Add. Okay, equal to. Now we need a function name, and let's call it as process GasTurb, and let's say file. And it's gonna have the file name only. File name. Can you write that? Thank you. Okay, this is done. And finally, we need to store those, and it actually helps me. So I'm getting this help, and I'm going to change those to Mach altitude. Trust map can stay, and no, let's say trust and SFC. Okay, now actually the code ends here. What we need to do is to create this function. So this is what we're gonna spend our time. So let's get back to the coding, and let's get to the end. And I'm gonna create the function. I cannot type function. And I can copy those here. Okay. And let's also copy this. Let's also copy this. Let's end the function. All right, so hardest part starts here. Okay, now let's read the data as raw data equal to read cell, because our data obtains both string and double, let's say. So I wanted to read as cell to get all the data in the file in the Excel sheet. I'm gonna get the file name here. I don't know why I've thought that much. Okay, I want to look at our Excel sheet. Okay, this is how GasTurb program yields us the Excel sheet. In the first column, we have the namings. As you can see, we have altitude here. That doesn't change, so this means the first altitude. And as you can see, the Mach number changes. Okay. And I get back here, and we got net trust and specific consumption. They all named in the first column. And as you can see, the trust changes as the Mach number changes. And yeah, that's all. After that, we have the second data cluster, let's say. We have altitude, this time it's 1000, and it stays the same. And we have Mach number, and it increases up to 1.6. And same behavior from trust and specific consumption as well. They're also increasing. So this is our file type, let's say. This is how the file behaves. So I need to somehow tell this to MATLAB that read this and obtain strings only, and first read the altitude, and altitude stays the same. And if you read the altitude, read the nearest trust, specific consumption, and Mach number as well, and that belongs to altitude, the first altitude. Then proceed with the other altitudes as well until all the altitudes are covered. So to do that, let's get started by say row headers. And this will be the string, as you saw, and raw data. And like I said, all the columns, all the rows and the first column. Okay, let's get down. Now we're gonna index the blocks. To do that, I'm gonna create the namings as IDX. Let's say first altitude, IDX, altitude, and let's say list. equal to. Now we're gonna find the altitude, and for that I'm using the find and contain functions, and it will have the raw headers, and it will search for altitude, and I'm gonna say that ignore case, and I'm gonna say true. So I'm doing the same thing for all of the data I need to extract: MAC, trust, and SFC. And this will be MAC. This will be trust. And this will be SFC. And this altitude, this is Mach number, because it is written down as Mach number here. This is, let's say, net trust. And this is specific fuel consumption. Like this. Okay. This means that now I can reach the altitude, Mach number, net trust, and specific fuel consumption. Now, let's get started by saying or defining a data that's called n blocks, and which equals to length IDX altitude list. First, let me tell you that what actually IDX altitude list does. Index altitude list does is that first of all, scanning all the strings here, and if it finds the string that's named as altitude, it stores it. This is the third row, and it goes down. There's an altitude, and here's the second altitude. This is the 133rd row, and it does that. So it will eventually store 17 amount of altitude data. And I say that perform what I'm gonna perform beneath here 17 times. So for of it, let me define the data blocks. Let me predefine the data blocks actually. All altitude, and I'm gonna add semicolons here because I forgot. Copy, paste, paste, paste. Semicolons as well, not colons, semicolon. Okay, this will be Mach. This will be trust, and this will be SFC. Okay, so I'm gonna start by the column 3, because GasTurb data usually starts from column 3, and as you can see, it starts from column 3. So I'm gonna scan from column 3 to the all the way to column, how much, I don't know how many. Okay, let's say that start column equal to 3. And now I can start my for loop. It actually helps me, but I said k equals to 1 to n blocks. Okay. And let's end the loop. Okay. Let me redefine the index altitude list as our altitude equal to, I'm copying this, I'm pasting here, I'm getting the first value of it. This means I'm gonna examine this. Okay, now I'm at this point. Now I need to find the specific rows belonging to this altitude block, which is the first one. So to do that, I'm going to say rMach equal to. I'm going to use the index Mach list to find the Mach number. And let's say find. And I'm going to say that index Mach length list bigger than our altitude, and assign it to 1. So what does this snippet do? It says that obtain all the Mach list that is bigger than the R altitude, which means all the Mach list here, and obtain the first data. So it's gonna scan all the Mach numbers, and it's gonna obtain 17 Mach numbers eventually, and the one stands for obtain the first one. So let's say we are at the second altitude. If the altitude is the second, this function scans from here. So the first Mach number will be this. I mean, not this anymore. Not this anymore. And the first will be that. This is how it works. I mean, it's a clever approach. So I'm gonna do the same thing. Same logic to trust and SFC as well. So I copy those, paste and paste, and this will trust. And this will be SFC. Okay, and let's copy those, trust list, and let's finally copy this to paste here. This is on for finding. Now I need to extract those data. So to do that, I'm going to say walls and altitude equal to cell to mat, because like I said, this is cell structure, and I need to obtain that to real numbers so that I can process them in MATLAB. That's why I'm using this cell to mat function, and it's going to call as raw data inside the columns actually, and it helps me. And finally, our altitude and start column to the end. Okay. Same for 3 of the remaining variables. It will be Mach, and this will be trust, and this will be SFC. Okay. You have to copy those. Here. Okay. Now, okay, I'm gonna add a robustness here, but we don't need that. But we should add that. I mean, I'm gonna first write down the function here, and I'm gonna tell what it does. Length, and it says walls Mach length wall thrust, and copy this actually, and finally this is for SFC. This prevents the error. How it prevents? Let's say that I don't know whether the GasTurb will make mistake, but let's say it made a little mistake and you have a data here instead of here. So you will have different vector length this will lead to error eventually. So we prevent that with this block. So this is not that essential if you believe in your data, but again, let's make the code much more robust. Anyways, that's all. So we need to have all the altitude, all the Mach, all the thrust, and all the SFC values. And it actually helps me here with those functions here. And let me hit the tab button. I can obtain all the data in the rows. For example, I'm going to obtain all the data here. That belongs to Mach altitude 0, of course, and any other values. And this is it. This is the function. And finally, this is not the function, this is the for loop actually. I need the grading. Well, the data we have now is scattered. Especially for the where's altitude, it starts from 0, 0, 0, 0, then 1000, 1000, 1000, 1000. It is scattered, so we need to use this scattered interpolation function, MATLAB built-in function to order the data we have. So to do that, we will create a structured mesh grid for lookup tables. So to do that, we're going to create a structured mesh grid, and I'm going to say that H vector, and that's a unique equal to. A unique function will help me to do that, and if I say altitude, and for M, which stands for Mach, unique, and I can simply copy this as well. And this will be all Mach. Okay, I can continue. And now I need to create the mesh grid. And this will have the M grid and H grid equal to mesh grid function. And of course, we're gonna input those. Okay, and finally, I can use the interpolation functions. So F thrust. I cannot type thrust. I don't know why. Scatter. Will it can help me? Yes. And open up. It says all Mach first. All Mach first, not all thrust. So do not trust the Copilot always. All altitude. All thrust. And it's gonna be linear. I'm gonna choose linear, and in here, let's say nearest. If I go further away from the analysis with it, let's say, but we scanned a really large flight envelope, let's say, from 0 to all the way 16,000 meters, and from 0 Mach number to 1.6 Mach number, which we will never reach. So let's put nearest here. So the last thing for SFC, so I simply copy this again and paste here, and this will be F SFC. Again, this will be all SFC. And same is wallet here. And don't forget to add the semicolons. Okay, and finally, let's create a trust map. It's again not trust map. Trust map equal to F trust and grid and H grid. And same for SFC. Okay, What says here? Haven't we created that? Okay, that's my mistake. Anyways, okay, we're done. This is the function. Let me separate it a little more so that we can separate from the main function. And yeah, I mean, if I run the code, it should work. Let's run the code. Are we gonna wait? Because, okay, we have a mistake. It says what? All Mac. In line 59. Walls Mac. Sorry. Run. It's SFP. I didn't change that. Where was it? In the function. SFC. Okay, where's SFP? Line 15. Okay. Also SFP. That's interesting. What is SFP? Okay, let's run the code. We have a mistake again. It says what? Was SFC again. Yeah, I'm doing lots of mistakes here. Where is it? Let's say 59 again. Walls. And I hope this now it works. Final. What is the mistake here? It says all Mac alt tuple. The input points must be specified in column vector format. Is it not? Of course they are not. We need to make them column vector format. To do that, I'm adding this. I'm sorry. And all for this. And I'm now hoping that it will work. Let's now run the code. And finally, what it says again. Okay. I have been debugging for a while. I did this mistake. I add a semicolon here. However, it created a vector, and it didn't work. It should create a row vector, not column vector, in order to obtain a grid matrix. And this was a M vector, but it should be a M grid and H grid for these two. And that's all. And like I said, if I run this, it will work. Okay. We have two different trust maps and CFT maps now. And I need to show you the maps by plotting, but I'm already, I mean, the video is so long already, so I'm gonna stop the video here and I'm gonna write the code about plotting and I'm coming back. Okay, I have added those parts and these two for plotting and finally saving the output. And let me run the code again and you will see the plots. By the way, as you can see, the struct data appeared here, so which means we successfully stored the data. And if I can find that here as engine data, as you can see, we have a struct. And if it opens, I'm gonna show you that what we've accomplished. And we have two different engine data, which is dry and wet. And in the dry, we have Mach, altitude, thrust, and SFP, but this will be SFC. And this as well. I mean, I'm doing lots of mistakes. I don't know why. Okay. Okay. Now we can look at the figures here. And this is dry. I mean, if I do this, you will see better format. And let's say light. All right. As you can see, with the dry thrust, we can barely reach 18 kilonewtons, let's say, at Mach number 2 and altitude 0. And as you can see, if I deploy the afterburners, I reach a really high points here. And if I can catch, there we go. This is not the point I would like to see. And this is the data that's 17.0.6. And as you can see here, we are very close to that. So this is sea level, actually, sea level and maximum 0. And yeah, these are the data. Okay, this was the idea. I know that video took so long, but I need to show you those because those, especially this function is so important when it comes to reading data from Excel sheets, let's say. That's why I took your time too much. But I thank you too much for your attending and watching. And I'm gonna share the clear code again in the descriptions. So I'll catch you later.